NASA's Hubble telescope has discovered an exoplanet that reflects almost no light, making it appear pitch black. The exoplanet in question is called WASP-12b, and it orbits a Sun-like star WASP-12a 1,400 light-years from Earth. Since being discovered in 2008, the exoplanet has become one of the best-studied and most insightful exoplanets ever, and these latest discoveries add to what astronomers know about distant worlds. In particular, the WASP-12b study sheds new light, excuse the pun, on what the atmosphere around WASP-12b is like, and how that compares to other exoplanets of a similar size. The results are also in stark contrast to other observations seen around similarly sized exoplanets, meaning astronomers can expand the knowledge of bodies outside the solar system. The discovery was made using the Space Telescope Imaging Spectrograph (SDIs) on the NASA Hubble Space Telescope by an international team from McGill University and the University of Exeter. The researchers used the telescope to measure what's known as an albedo to reveal how much light the exoplanet WASP-12b reflected during an eclipse in October 2016. This was when the planet was near full phase and passed behind its star, making it the perfect time to determine the albedo because it involved directly measuring the amount of light being reflected. This required a precision 10 times greater than traditional transit observations, though, which is one of the Hubble Space Telescope's imaging spectrograph's strengths, letting scientists measure the albedo of WASP-12b at different wavelengths. WASP-12b has a radius almost twice that of Jupiter, and 1 year on the planet lasts a little longer than a day on Earth. As such, WASP-12b is categorized as a hot Jupiter. Because WASP-12b is so close to its star, the gravitational pull of WASP-12a is said to have stretched WASP-12b into an egg shape and raised the temperature of its daylight side to 2,600 degrees Celsius. This high temperature is the most likely explanation for WASP-12b's low albedo. There are other hot Jupiters that have been found to be remarkably black, but they are much cooler than WASP-12b. For those planets, it is suggested that things like clouds and alkali metals are the reason for the absorption of light, but those don't work for WASP-12b because it is so incredibly hot, explains Bell. The daylight side of WASP-12b is so hot that clouds cannot form and alkali metals are ionized. It is even hot enough to break up hydrogen molecules into atomic hydrogen, which causes the atmosphere to act more like the atmosphere of a low-mass star than like a planetary atmosphere. This leads to the low albedo of the exoplanet. The results were surprising. According to lead author Taylor Bell from McGill University, the measured albedo of WASP-12b is 0.064 at most. This is an extremely low value, making the planet darker than fresh asphalt. This makes WASP-12b 2 times less reflective than our Moon's albedo of 0.12. Bell added, the low albedo shows we still have a lot to learn about WASP-12b and other similar exoplanets. After we measured the albedo, we compared it to spectral models of previously suggested atmospheric models of WASP-12b, explained co-author Nikolai Nikolov from the University of Exeter. We found that the data match neither of the two currently proposed models. The new findings indicate WASP-12b's atmosphere is made of atomic hydrogen and helium. WASP-12b is only the second planet to have spectrally resolved albedo measurements, the first being HD 189733b. While HD 189733b has a deep blue color, WASP-12b is not reflecting light at any wavelength. WASP-12b does, however, emit light because of its high temperature, giving it a red hue similar to a hot glowing metal. The fact the first two exoplanets with measured spectral albedo exhibit significant differences demonstrates the importance of these types of spectral observations and highlights the great diversity among hot Jupiters, concluded Bell.